You know what I wonder? Where do those stars actually come from? All that light up there.
Hey, before we dive into that, don't forget to subscribe to our channel. That way you won't miss any amazing stories about the universe. Take a good look. See that nebula over there? That soft, colorful haze?
Yeah, it looks just like a painting. What is it exactly?
That's a nebula. A cloud of gas and dust. Very old and very large. There are different types of nebulae in space. Some glow because they're lit up by stars. Those are called emission nebulae. Others just reflect light, reflection nebulae, like a cosmic mirror. And then there are dark nebulae, where stars are still being born, but the dust blocks the light.
It's like these nebulae tell the whole story of stars.
Exactly. Inside a nebula, there's mostly hydrogen, the lightest and most common element in the universe. Everything starts with hydrogen. Think of it as the building block of stars. In the quiet vastness of these nebulae, something miraculous begins. Sometimes a shockwave from a nearby star explosion stirs the gas, or a collision with another cloud. That movement lets gravity do its work. The gas and dust start clumping together, getting denser and hotter.
So chaos creates order?
Yeah, the universe works like that sometimes. Beautiful things come from chaos. The core of this collapsing cloud becomes a protostar, a kind of baby star. It's already hot and heavy, but not a real star yet. When it gets even hotter, millions of degrees, something magical happens. Nuclear fusion.
Nuclear fusion? That sounds complicated.
Actually, it's pretty simple. It's like hydrogen atoms holding on so tightly that they fuse into helium. That makes the star warm, and most importantly, it makes it shine. That spark of energy is what we see as light and heat. Stars come in many kinds. They're classified by temperature and color. We call these spectral classes.
Color? Like they're in a star club?
Yeah, the coolest stars are red, called M class. The hottest stars are blue, called O class. In between are orange, yellow, and white stars. Our sun, for example, is yellow, a medium star.
How do scientists know all this?
With special telescopes and spectroscopes, they study the light from stars. Stars also differ a lot in brightness, how brightly they shine. From small dead white dwarfs to huge hypergiants that almost light up the entire universe.
What happens when a star reaches the end of its life?
Most stars burn their hydrogen slowly, like our sun. When it's gone, our sun will blow off its outer layers and become a white dwarf surrounded by a beautiful planetary nebula. But big stars take the spectacular path. A supernova, a giant explosion that blasts everything away. What's left after that explosion can be a neutron star, a celestial body, so dense that a teaspoon of it weighs as much as a mountain. Or if the star was even heavier, it collapses into a black hole, a place where gravity is so strong that not even light can escape.
That sounds like something out of a movie.
The universe is sometimes more dramatic than fiction. Maybe the most beautiful thing is that all that stardust. That's what we're made of.
Wait, we really are stardust?
Everything alive is made from elements formed inside stars. Carbon, oxygen, iron, all forged in the fires of stars. That dust spreads through the universe, forming new stars, planets, and eventually life. So when you look up at the night sky and feel small, know that you're also a piece of that light. We're all connected to the universe, part of that enormous cosmic dance.
That's beautiful, like we're all a little bit stars.
Exactly. And maybe that makes everything feel a bit less vast and unreachable. If you want to hear more magical stories about the universe, don't forget to subscribe. That way, you'll always stay connected to the wonders of the cosmos.